Page 14 of quadratics. Here at number 4, we are going to try to find the equation of each one of these quadratics based on the vertex and the axes intercepts. So, of course, if they give us the vertex, then probably the form of quadratic equation that we're going to use is the vertex form, right? Where h and k are the coordinates of the vertex. So, for example, for a here, the coordinates of the vertex are 2 and 4. So our equation is probably going to look like this: x minus 2 squared plus 4. And then we just need to figure out what a is. How can we figure out what a is? Well, kind of like what we did before. If we have a intercept, and here it looks like the intercept is 0, 0, that would be the x-intercept and a y-intercept. We can put 0, 0 in the equation and then see what value of a is going to make that true. So we're going to put 0 here and 0 here. So it's going to be 0 equals a times negative 2 squared plus 4. Negative 2 squared, negative 2 quantity squared is 4. So it's 4a plus 4. So 0 equals 4a plus 4. So we're going to subtract 4 from both sides. We're going to get negative 4 equals 4a. A equals negative 1. Okay, so our a value turns out to be negative 1. Alright, let's go to b. So in b, the h and k values are 2 and negative 1, so we can already write out the equation. It's going to be a times x minus 2, quantity squared, minus 1. So what would be our a value? Well, we can see that we have the y-intercept. The y-intercept is 7, so the coordinates here are 0, 7. So I'm going to put 0 in for x, I'm going to put 7 in for y, and then what value of a would make that true? Well, 0 minus 2 is negative 2, quantity squared is 4, minus, so that's 4a minus 1. So it's 7 equals 4a minus 1. Add 1 to both sides, we get 4a equals 8. And then divide 4 both sides, we get a equals 2. So this a is actually equal to 2. Okay? Getting used to this? It's not too bad, is it? Okay, so for this one here, again, the h and the k values are given in the vertex, so that means the equation is going to be a times x minus 3 quantity squared plus 8. So we need to figure out what the a value is. We can do that by looking at the intercept. So the intercept here is going to be 1, 0. So we're going to put 1 in for x, and we're going to put 0 in for y, and then we'll see what we get. So we have 0 equals a, and then 1 minus 3 is negative 2, quantity squared, so it's 4, plus 8. So it's negative 8 equals 4a. A equals negative 2. So, put negative 2 there. Whenever we get an a value that's negative, that means that the parabola opens down. So, we can just confirm that our algebra is correct by making sure that the picture also opens down in the case that a is negative. Okay, so now we're going to look at D. We know that the h and k values are here, so we're going to say a x minus 4 quantity squared minus 6. The a value we're going to find using the x-intercept 7, 0. So we're going to put 7 in for x, and we're going to put 0 in for y, and we'll have 0 equals a times 7 minus 4, which is 3, squared, which is 9, minus 6. So now we have 9a equals 6. So a is equal to 2/3. Put 2/3 here. Okay. E. So E, we got h and k values here. Y equals a times x minus 2, quantity squared, plus 3. And then the point that the parabola goes to is 3, 1. This isn't an intercept, it's just any point, which is fine also. We're going to put 1 in for y and 3 in for x. We're going to get 1 equals 3 minus 2, which is 1, quantity squared, which is 1. So we got 1 equals a plus 3. And then we subtract 3 from both sides, and we get a equals negative 2. So we can say that the a value here is negative 2. Since it's a negative a value, you can see that it opens down. Okay, for this one here, we have a h and k value of 1/2 and negative 3/2. So we're going to put those into our equation. X minus 1/2 is quantity squared minus 3/2. Then we're going to take this given point here, which is x equals 3/2 and y equals 1/2, and we're going to see what value of a makes that true. So 3/2 minus 1/2 is 1, so 1 squared is 1, so we get this equation, 1/2 equals a minus 3/2. We're going to add 3/2 to both sides, and that will give us 3/2 plus 1/2, which is 2, equals a. So our a value is 2. This last half of the worksheet, we're going to be doing a different kind of problem than what we've been doing. You know, if you have a parabola and you have a line on the same graph, there's a chance that these two are going to intersect each other. And there's 3 possible ways that a line and a parabola can intersect each other. They can cross at 2 points, like here, it's called cutting. They can be barely touching, which doesn't necessarily have to be at the vertex. You can see since this line is diagonal, it's not actually touching the parabola at the vertex, but it is touching at 1 point, not at 2. And finally, there's the missing scenario where the parabola and the line completely miss each other, no points of intersection. This may remind you a little bit about the way a parabola crosses the x-axis, and it is really related. Okay, let's take a look at this example. The way you do these problems is you take the 2 equations. You have a line equation and you have a parabola quadratic equation. And if these two intersect, then one thing you know for sure is that this x is the same as this x, and this y is the same as this y. Because if it intersects, that means that there is a yellow and purple xy pair which satisfies both equations at the same time, which is the definition of an intersection. Okay? So how do we find that x and y? Well, if we assume that the purple y's are the same, then what we can do is we can say that these are the same, and we'll make the right-hand sides of each one equal to each other. So that's what they did here. They have the parabola equation y equal to the line equation y. And then, now that they made this equality, then they're just going to use algebra to simplify it, and they'll see that it turns into a quadratic. The combination of the quadratic and the line equation put together just becomes a different quadratic. Then you can, and you notice that since they took everything from the right-hand side is now 0. So to solve this, to find the values of x which make this true, they can factor, or they can use quadratic formula, or they can use the calculator. And what they find out is that x equals 5 and x equals negative 3 are the two solutions, the two possible solutions for this yellow and purple coordinate pair, which shows the intersections of these two graphs. Now, of course, 5 and negative 3 are not a coordinate pair. It's only the x coordinate. So how do you get the y coordinate? Well, you can take the x coordinate, 5, and you can substitute it into either the quadratic equation or the line equation, either one. Now, of course, the quadratic equation is much more complicated, so it's easier if you plug it into the line equation. So that's what they did. So when they put 5 into the line equation, they found out that the y value is 2. When they put negative 3 in the line equation, they found out that y equals negative 6. So now they know that the graph meets at 5, 2, or negative 3, negative 6. Okay? So now let's do a couple of these problems to see how it works. So we have this quadratic and we have this line, and we're going to assume that the y's and the x's are the same. When we assume that they're same, that means that we could just set them equal to each other. So we're going to do that. Equals x plus 6. And then we can subtract x from both sides, and we'll get subtract x, subtract x. We can subtract 6 from both sides, and we get subtract 6, subtract x. Now the right-hand side has been reduced to 0. The left-hand side is now x squared negative 3x plus 2. And then there's several ways we can find the roots here. Just to make things go quicker, in this case I'm going to factor. So I'm going to put x minus 2 and x minus 1. That happens to the factor pair for this. And so we know that the two possible solutions here are x equals 2 and x equals 1. And then we just want to know what the y coordinate, which corresponds that to this x equals 2. So we're going to put 2 back into the original line equation, because it's the simplest equation. Now notice if you plug it into this equation, it's just going to give you 0 because it's a root of this equation. We need to plug it back into the original equation to find the y coordinate that corresponds to this x equals 2. And it turns out to be it's y equals 8, right? What about x equals 1? If you put x equals 1 in here, then you get 1 plus 6, and you find out that y equals 7. So these are the two pairs of coordinates which work for the A pair of quadratic and line equations. Okay? Now let's look at B. So for B, we got another set of quadratic and line equations. We're going to set them equal to each other because we're going to assume that they intersect. 2x minus 3. Now we're going to make the right hand sign 0, so we're going to subtract 2x from both sides. We're going to add 3 to both sides. And so we're going to have negative x squared plus x plus 12 equals 0. And now I'm going to factor. You can use quadratic formula here, but I found out that if I factor it into negative x plus 4 and x plus 3 equals 0, then I can find the solutions here. So the two x solutions are x equals 4, because x equals 4 would make negative 4 plus 4 equals 0, or x equals negative 3. And then I can find the y values here by taking 4, and I'll plug it back into the original line equation. So I can put 4 in there, and I'm going to have 2 times 4, which is 8, minus 3, which is 5. Then I'm going to put negative 3 in here, and then I'll get negative 6 minus 3, which is negative 9. Okay. So these are the two possible coordinate pairs which make both the quadratic and the line equation in part B true at the same time. So in these first two cases, the quadratics touched in this manner, right? Because they intersected at 2 different points. Now, since it's the book, some of these are not going to intersect at 2 points, because the book is going to give us different kinds of problems, not always the same kind of problem. Okay, so I'm doing part C, and I'm going to do the same thing. I'm going to set the line equation equal to the quadratic equation. Then I'm going to subtract the 2x to move it to the left. I'm going to add 6 to move it to the left. And so the right side is now 0. The left side is x squared minus 6x plus 9. I can factor this into x minus 3 times x minus 3 equals 0. So the solutions are 3 and 3. And then I'm going to take this 3 and I'm going to plug it into the original line equation, which is over here. And then I'm going to put 3 in for x, and it's going to be 2 times 3, which is 6, minus 6, and it turns out that the y value is 0 that corresponds to this. Okay? So, and you see that like it only has one solution, x equals 3. So that means that there is only one point that the parabola is going to touch the line, kind of like this drawing here. Okay, so this is touching. Touching. At one point. Okay? Alright. Now let's do the last one, which is D. Okay. D. So I'm going to take the two equations, which is the parabola equation, and set it equal to the line equation. And then I'm going to subtract 5x from both sides. And then I'm going to add 4 to both sides. And then I'm going to get negative x squared minus x minus 3 equals 0. And then I'm going to try to factor this. And I'm going to use the quadratic formula. So I'm going to use b squared minus 4ac to see if this is able to be factored. So I'm going to put negative 1 for b minus 4 times negative 1 times c, which is negative 3. So this is going to give me the square root of 1 minus 12, which is going to be negative 11. So it's the square root of negative 11. So the discriminant is equal to the square root of negative 11, which is the discriminant is equal to negative 11, which means it's less than 0, which means there are no solutions to this quadratic. So we know now that no solutions. So that means it's this case here where the quadratic and the line don't touch each other. So no solutions, no intersections. Okay? And now we're done with this section.